So here's what the finished product looks like on the, would that be right side landing gear. And you can see when it is in the sprung position, it's nice and aligned properly. So you've got the proper amount of camber and the proper amount of toe in. But that's a little bit difficult to actually visualize with just the short length of the wheel to use as a reference. So I think for the other side what I'm going to do is recommend leaving the axle long. This is too long, of course, but leaving it long like this so that when you put it from the unsprung to the sprung position, it's a little easier to verify that it's in the right spot, that you've got toe in, some but not too much, and if you kept that the same on this side, a long shaft there too, you'd easily be able to verify how much toe in you have and that it's equal on both sides. And then of course once you come to the horizontal, you want to make sure you have no camber, because naturally in the unsprung position you get all kinds of funky things happening with the geometry here. So the pieces that go in here that I found worked include these little things here, these little eyes that were used back in the olden days when servos came with rubber grommets to isolate them from engines, the old IC two-stroke engines. So the rubber grommets had this brass eyelet as well. I've got tons of these things. I never threw any of them out. Don't know why, but I guess now I've got a use for them. So the idea is you take one of these guys and you run it on the shaft, the axle. See if I can get the camera to focus properly here. And we're going to create a thrust bearing with this thing. So it'll hold the wheel in the right position. Obviously it'll prevent the wheel from moving any further in. And the wheel itself, you can see a brass tube in there. Just friction fit, that's all it needs. Flush on this side, recessed on this side. And the reason for the recess will be apparent in just a second here. So you slide the wheel on the axle so that brass is in contact with brass. Brass on brass. And then the second eyelet is what you used as the other thrust bearing. So it goes on here like this. And the, let's see if we can focus that better. There we go. And the skinny end, the part without the flange, goes inside the wheel, like that. And then use a Dremel to cut off the wire, the axle, and then a spot, just a spot, of epoxy or CA on the end, and that will hold everything true. So again, once you've got this all set up, you can easily verify toe in from this angle, and camber from this angle. It's not right. What you do is you adjust the bend on the axle. So a big trick is of course getting this angle right on the axle, and what I proposed doing was just taking a piece of brass which bends easy and cut a little piece as a trial and try it out. Stick it in your wheel, check out the geometry, make sure you like what you see, and then once you do, commit to the solid piece. This is just wire rod here, music wire, and you can use the smaller piece as a template to verify your work. So just stick it in the grips and verify you've reached the same. And leave it long, like I've done here. Leave this piece here long. First of all, it's a lot easier to bend when it's long like this rather than trying to cut it to length and then bend it. And secondly, it helps with alignment. Here's what I mean about the value of leaving the axles long. Before you trim them, make sure you check your geometry. So in the unsprung position, who knows what's going on, right? There they are. But as you go to the sprung position, that's the part that matters. And here you can check to see that you're happy with the toe in that you've got, that the amount is okay, and it's equal on both sides. Not rocket science. Clearly there's slop in the landing gear, so only worry about getting up close. So looking at it from the front now, here again you can verify that you have the proper camber. Something that looks eye-pleasing, really, I think is what we're going for here. There's so much slop in the landing gear that you're not looking for precision. The long axles just make it all that much easier to see. So here, as I put them in the sprung position, you can see that I do have a small amount of positive camber in the wheels. What that'll look like once they're actually on the ground and rolling with some pressure on them, who knows? But I think this is likely close enough for my purposes. So here's what the landing gear looks like in its completed state. And I don't know, but to my eye, that does look better than the extreme camber on the stock arrangement. And of course the last thing to do is to make sure all the weird dimensional changes I've made to the landing gear with that standoff and the different angle of the wheel relative to the gear is all going to retract properly. So no problem. Now on the other side, I did have to sand a little bit away to get it to work. I don't have this side plugged in, but I also have some matching gray paint that I picked up from Home Depot that is a great match to the color. I'd say 99%. And I'll just touch that area up there that you see with some touch-up paint, and no one will be the wiser. I'm sure if I played with the geometry a little bit more, if I played with the position of the ball links, the length that each is separated from the other, and where this link is relative to the shaft angle, I could probably have gotten away with not sanding. But honestly, there's just an endless amount of parameters you can play with to get this to work properly, and I'm pretty satisfied with the look of the gear, both in the landing approach with the slight toe out, played out, splayed out look, as well as of course when it's taxiing on the ground.